Hey, what's going on, guys? Let's see how we can integrate this function right here. So we have sine square cos square dx. So when we have even positive powers, we can't really use this one right here. So we usually use this one when we have odd power, even power, like we have something like cube, something like that, right? But for this one we have both are square, so we have to do something about this. So usually in this kind of things, what we do, we apply the uh, trigonometric identities. So we have three trigonometric identities that is generally used. That is cos square x is equal to half 1 plus cos 2x, and the second one is sine square x is equal to half 1 minus cos 2x, and the third one is sine 2x is equal to 2 sine x cos x. So these are the generally used trig identities, but in this case we can use these two. So let's use these things. So this is going to become, when you substitute this sine value, this is going to be half 1 minus cos 2x, half times half. Instead of cos square x, I'm plugging this one. This is going to be half times 1 plus cos 2x dx, right? And what I can do, I can bring this constant to the front. So 1 half times 1 half is going to be 1 over 4. So 1 over 4 to the front. So we are left with 1 minus cos 2x, 1 plus cos 2x, and that is the one we have left with. And if you notice this one, this is like x minus y, x plus y pattern. So when we have x minus y times x plus y, that gives us x square minus y square, right? So that's what we are gonna get right here. So this is gonna be 1 over 4 1 square minus cos square 2x. So this is what this is gonna give, and times dx. So we have left with this one right here. So let's simplify a little bit. So 1 square is going to be 1 over 4 integral 1 minus cos square 2x dx. So since we have a square right here, so we can use this one again to simplify this one. So this is going to be 1 over 4 integral of 1 minus, instead of cos square 2x, I'm going to use this one. But if you notice this one, when we have x right here, it's doubles right here, 2x. When we have x, this is 2x. Since we have 2x right here, this is going to be 4x. So this is going to be half times 1 plus cos 4x dx, right? So this is the function we have right here. And now what I'm going to do, since we have 1 minus half, so let's eliminate this bracket. 1 over 4 integral 1 minus half. So let's multiply by half first. So 1 right here, 1 half plus half cos 4x times dx. So let's eliminate this bracket right now. So this is going to be 1 over 4 integral 1 minus half cos 4x times dx. So 1 minus half is going to be half, positive half. So this is going to be 1 over 4 positive half minus half cos 4x dx. And if I now what I can do is I can simply separate this into two integrals. So this is gonna be, I continue this one right here. So this is gonna be 1 over 4 bracket integral of half. So I had to multiply dx, both of these one by dx. So if I multiply this one by dx, this is going to be half dx. This is easy to integrate. And the next one is going to be half cos integral of half cos 4x dx. For this one we have to do something. So if I integrate this one right here, this is just going to be half time x, because integral of dx is going to be just x. So this is going to be half times in the bracket half x minus, for this one what I can do the juice substitution. So let's write this one first. Let's take the half to the front. So half, since it's a constant, I can take to the front. Half integral of cos 4x dx, right? So 4x, and I'm going to take this 4x as u. So u substitution, I'm going to do the u substitution. I integrated this one already. This is, we don't have to worry about this one. We only have to integrate this one right here. So let's do the u substitution. So let's take u as 4x. So if I take u as 4x, I have taken care of this one, but we have to take dx. We have to do something for the dx right here. So what I have to do, I can take the derivative of this one. So du is going to be 4 dx, right? This is going to be the derivative. Since this is just dx, I have to write this one in terms of dx. So this du by 4 is equal to dx. Now I can write this whole function in terms of u. So this is going to be, I continue this one. Yeah, let's write this one right here. So this is going to be 1 over, this is 1 over 4 actually. This is 1 over 4. So 1 over 4, let's multiply this one right here. So this is 1 over 8x minus half integral of cos, instead of 4x I plug the u, so this is going to be u. Instead of dx I plug this du by 4, so this is going to be cos u times du by 4. So now I have written in terms of u. I can bring this 4 to the front. It's a constant, so I can bring it to the front. Let's continue this one right here. Okay, I separate this part. Okay, I write this one right here. So this is going to be 1 over 8x minus 1 over 4 times 1 over 2. This is going to be 1 over 8 integral of cos u du. Now this one is easy to integrate, because integral of cos u is just sine u, and the final answer is going to be 1 over 8x minus 1 over 8 sine u. Now all I have to do is simply substitute the u value. So we have the u value, that is 4x, so that's going to be the final answer. So final answer is going to be 1 over 8x minus 1 over 8 sine 4x plus constant, and this is the final answer. I have made a mistake right here. So we have this 1 over 8 this 1 over 4 is common for both, right? This 1 over 4 is common for both. That's the mistake I made. So I had to multiply this both by 1 over 4. I forgot to do that. So let's do that. So this is going to be 1 over 4 times 4. yeah, 1 over 4 times 4 16. 1 over 4, so 1 over 4 times 1 over 2, 1 over 8. So 1 over 8 times this 4, this is going to be 32. So 1 over 8x minus 1 over 32 sine 4x plus constant. And that's the final answer. I hope you guys like this video. See you next time.